Hi, my name is Adam Wood, and this is a discussion of the use of thorium in a breeder reactor. First off, I'm going to give you a little background on the history of thorium. In 1829, John Berzelius discovered thorium. He was given a sample of a mineral with an unknown substance in it from a friend of his, which he ended up discovering as thorium. He named thorium after the Scandinavian god Thor, and was actually a name he reused from in a terbium sample he had found the year before and had misunderstood what it actually was. 69 years later, in 1898, Marie Curie discovered that thorium is radioactive. Then come to 1946, Alan Weinberg wrote a paper proposing an idea for a pressurized water reactor. He ended up gaining a patent to design one of these pressurized water reactors. In the process, he proposed a breeding cycle for thorium-233. This process would not be used until 1977 at the Shippingport nuclear power facility in Pennsylvania. In 1956, Weinberg proposed a program to develop the molten salt reactor and was given approval in 1957. This was to begin a civilian reactor program with Oak Ridge National Laboratory with approval from the Atomic Energy Commission. This was known as the Molten Salt Reactor Project. Now to better help you understand the thorium life cycle, we're going to go into a little more depth on thorium used. Thorium is used as a blanket for the fuel. Thorium-232 is thorium in its natural state. During fission, thorium absorbs a neutron and becomes thorium-233. Thorium-233 decays with a half-life of about 22 minutes. It decays into protactinium-233, and the downside of this is that protactinium acts as a neutron absorber and can slow down your nuclear reaction. Protactinium-233 has a half-life of roughly 27 days and takes roughly a month to produce uranium-233, which uranium-233 is an ideal fuel. Whenever the uranium-233 is used as a fuel, it releases energy and neutrons to continue the process. The downside is that this process takes roughly a month to breed the uranium-233. Back to the history, in 1962, the Indian Point 1 reactor in New York, which was a pressurized water reactor, used highly enriched uranium-235 as a fuel and used thorium-233 as a fertile material. In this case, it was found that more uranium-233 was produced from thorium-233 than plutonium-239 was bred from uranium-238. The uranium-233 that was bred was given to the molten salt reactor project. This was later given to the molten salt reactor experiment. The molten salt reactor experiment gets off the ground in 1965. In 1968, they reached criticality, but thorium was not being used at the time. In 1969, the molten salt reactor experiment reached full power using uranium-233. This uranium-233 was bred from the previous reactor from Indian Point in New York. Later in 1969, the molten salt reactor experiment was shut down due to the molten salt reactor project constraints. In 1977, an experimental pressurized water reactor at Shippingport is loaded with the uranium-233 and thorium-233 core in order to test the feasibility of thorium-233 in conventional pressurized water reactors for use as a breeder reactor. This core ran for 5 years and in 1982 was pulled from service. After studying the core afterwards, It was determined that about 1.4% more fissile material was in the core than when the experiment began. This proved that thorium can be successfully bred into uranium-233. Unfortunately, due to financial, political, and technological constraints, no more pressurized water reactors have been converted to light water breeder reactors. Fortunately, many countries, including our own, have started to regain interest in this promising design. Thanks for watching.